Can anybody hear me?
No, I can't hear what you're saying.
Good. That'll be perfect.
Super duper. Who was that?
You didn't think I was going to make it here, did you, John? You thought I was going to stay in South Wales.
It crossed my mind at some point. I'm sure you might want the record top.
The paper that is the book, the first is Visualizi, which is going to talk about research themes and interactive paper visualization.
Thank you very much. Can everybody see my screen?
I can, yes.
Okay, good, good. I hope that other people can see it as well and everybody can hear me. Thank you very much for inviting me to give this presentation, and thank everybody for waking up who's woken up to watch it. It'll be interesting to try to summarize the research themes in only 10 minutes or so, but I'm going to do my best.
Is it possible to put your slides on full screen? Well, you can see them, it's not the other way, but it's easy.
Yeah, let me see. Does that's about as big as they get. Is that okay?
Yes, that's fine. I think yeah, that's it.
Does that help? Yeah.
That's the one.
Okay, so this is just a little bit of background since nobody knows really who I am. Well, there is one member of staff that knows who I am, so to speak. But anyways, I was born in Boston, and then I went to the University of Massachusetts, Amherst, and studied physics for some years. And then I studied computer science at the University of New Hampshire. And after that, I went across the Atlantic Ocean. That dashed line represents the Atlantic Ocean. So that's a trip from New Hampshire to Austria. And I lived in Austria for 5 years, and that's where I wrote my PhD, also in computer science at the Vienna University of Technology. From Austria, I went to South Wales, and I was working at Swansea University for a while. And then after Swansea University, I came to Nottingham just this year. And then as soon as I got to Nottingham, the lockdown happened. So, yeah, that's a little history, a little background. And if anybody knows the answer to what people from Massachusetts are called, you get a free beer. Free beer on me if you know the answer to that. Okay, so the research and data visualization, generally the unsolved problems and the research falls into these categories as a very broad overview. So what we do in data visualization is try to solve problems related to the following themes. The most common theme is large data sets. So I think we all can agree that we're better at collecting and archiving data than we are at actually extracting value and information and knowledge from the data. So our ability to collect and archive data is always far ahead than our ability to extract meaning and information from that data. And this is probably the most interesting aspect of data visualization, is the ability to extract knowledge and information from very, very large data sets. We spend a lot of time thinking about intuitive visual metaphors and designs. So a lot of the metaphors and visual designs and information visualization, they're generally man-made, they're generally synthetic, they're generally just a product of imagination. So we spend a lot of time just thinking about, okay, what might be an intuitive visual metaphor for a given data set. That might not be true for the scientific data sets, but that is certainly true for the abstract information-based data sets. We spend a lot of time thinking about novel interaction techniques and also the speed of computation that's necessary to support interaction. So interaction is a very prominent theme in data visualization. And so we spend a lot of time just thinking, okay, what would be some more advanced, some novel interaction techniques for a given data set? And how can we make sure that that interaction is maintained at a certain frame rate? For example, 5 frames per second. 5 frames per second is what we usually call interactive frame rate. Perception is another very common theme. So how do people actually perceive what they see? Do they understand what they see? For example, how many dimensions can a person process at the same time when they're looking at it? How well do they perform certain tasks? How quickly can they perform certain tasks? What's the error rate involved in performing certain interactive tasks? Very common theme. Another very common theme is high-dimensional data. So we do deal with very high-dimensional data, for example, 100 or 200 dimensions. And I've thrown in time in there, so that includes time-dependent data. What's a good way to visualize time-dependent data in such a way that it can be understood and analyzed? Uncertainty is also a research theme in data visualization, how to represent and process uncertainty. By default, it is just thrown in as another dimension into the high-dimensional data viz category. But how to treat it as in a special way and represent it in a special way such that it's not just another dimension of the data is, I would say, an unsolved problem. And then combinations of all these themes are active areas of research. These are generally the themes that I could think of that almost all of the research falls into. And these are some of the themes that we have actually worked on or still work on. So my PhD, for example, is in the visualization of computational fluid dynamics data. So that's in conjunction with engineers, and the focus of that was motor simulation data. That's still a very active area of research. Well, CFD is not limited to motor simulation, it's all fluid flow modeling. We have done work in foam visualization. That's a very specialized area, I would say. That actually is a collaboration with computational physicists. Probably there's nobody else doing foam simulation at Nottingham University. Another active area of research is computational biology. This is quite a popular topic. So it's the study of molecular dynamics and molecular interactions. And there are very, very large groups of computational molecular dynamicists working on this problem. And that's a very active community inside the UK. We've done work with marine biologists, so marine biologists that actually go out into the wild and they capture animals for example, cormorants or anything that's deep sea wildlife, and they attach digital sensors to those animals, release them into the wild, and they'll swim for some hours or for some days. They'll recapture the animal, recapture the digital sensor, and then try to figure out what happened, what the animal did during that time they were wearing the sensor. We've worked with sports scientists, so if there are any rugby fans out there, I have never actually watched a game of rugby in my life, but I have been studying the rugby analysis for several years, and we did a nice visualization collaboration on how to visualize. That's essentially how to visualize the events inside of a rugby game. So instead of actually watching the game, you can just see a visual representation of all the events in the game and get an overview of the game, for example, in only a few seconds. Another active area is visualization of Shakespeare's Othello. This is one that British people love. Not only British people, but German people love this too. So Othello, for example, has been translated into German more than 50 times. And one of our projects is to study those translations and how they change over time. So they change and evolve over time. And the way they change and evolve over time reflects the historical events of the era and the political events of that era in which they were translated. They also reflect some of the characteristics of the translators themselves. But how to actually visualize that information is certainly a challenge. Another area we work in is the visualization of call center data. So that's both customer-centric data and employee-centric data. So it turns out about 4 to 5% of the adult working population in the world globally works in a call center. So it's actually a very important problem. And we work with a company based in Birmingham that writes software, that database software, and that database collects all of the information about what happens, what transpires in a call center. From the time somebody calls, how long they navigate through the IVR, how long they're put on hold for, which agents they talk to, if they get transferred around the call center, which departments they get transferred to, and so on. So how to visualize, for example, millions of call events over a time span of days or months or years is a very challenging problem. We work on geospatial visualization. There's a very hot topic right now. I don't know if anybody else in the department is looking into this, but smart cities and smart city data. This is an up-and-coming topic, and we are working on the visualization of smart city data in conjunction with geospatial visualization. We're also looking at the visualization of healthcare data. So data from Public Health England, and we're also looking into ways to visualize electronic health records. I am also involved in an effort that visualizes the pandemic-related data, so the COVID-related data. So we're working with the people that simulate the simulations, and then they output some data, and then we do our best to visualize it. We have an active research theme in visualization literacy and education, studying what the cognitive and perceptual barriers are to understanding visualization, and what people can understand and what they can't understand, why, and trying to figure out why they can or cannot understand what they see. And I just made some notes about future directions. So these are all current active areas. some future directions which I expect will be very, very interesting. They're not quite there yet, but I expect them to be very important in the future, are fintech visualization and legal tech visualization. So advanced visualization techniques to support financial data, the analysis and exploration of financial data, and legal tech visualization. So anybody involved in law studies or searches massive volumes of unstructured text, and I'm sure they would be very interested to see how that search process can be accelerated with visualization. Okay, there are some images that sort of summarize some of the themes that we've been working on. If this was a longer talk, what I would do is I would actually ask the audience to vote on one of these topics, and then I would go into that topic in more detail so you could see an example. In the interest of time, I will just quickly demo one project that we just recently published. Tony, you have to tell me when I should stop, by the way, probably in like 2 minutes or something. I can't actually hear you. Okay, yes.
Yeah, we're running a little over, so another minute or two.
Okay, what I'll do is, instead of showing this demo, I will wrap up. And let's see here. I will just mention that I do have a YouTube channel, and all of the research that we do goes on this channel, and there are playlists dedicated to a lot of these topics. For example, like text visualization, or different talks that we do, different research videos. This is a playlist dedicated to flow visualization. This is the playlist dedicated to visualization of call center data, and so on. We even have practice PhD, Viva, and defense talks on there. We have a lot of material on there. So if you're interested more in these different themes and want to see them in detail, you can do so on the channel. Okay, I think I'll stop there because my time is probably up.
We're asking a lot to do this in a short period of time, but that's good, thank you. Are there any questions for Bob? So somebody has got their hand up for it. Can't see who it is.
It's me, Michel.
Okay, Trevor.
Very easy. I was wondering, have you ever done any data visualization, or do you know of any large data visualization activities around human behavior understanding, but I mean then expressive human behavior? So the way people over long periods of time in particular behave, because this is something that we are increasingly working on. We've worked on facial expressions and facial body actions for short periods of time, but we're now looking more at how they behave and change their behavior over weeks and months and years even. So we're now struggling with a completely new way of having to visualize all that data. Are you aware of any work in that area?
There is an area of visualization called Personal Viz, which does focus on the visualization of data associated with the way people behave, and on a personal level or on an individual level. And there is quite a trend right now in devices that we wear on our wrists, like Fitbits and smartwatches, Apple Watches. Amazon just released a new wearable device that collects data on our behavior that's more advanced than the current products out there. So there is work on that, and there are people studying that. Yes.
But is there anything more, let's say, more physical? So we don't seem to think of ourselves as bits of, as bits of data, but more as our posture or our expression, or things that we understand ourselves. But how do you visualize, let's say, how many times you jump or smile or frown over time with vignettes or things?
Well, any data that is associated with motion is certainly people including myself, have studied that kind of data. So the animal sensor data is all about studying the behavior and movement of marine wildlife over a period of either hours or days. In terms of facial expressions, that would be more of a computer graphics topic. So there are lots of people that study facial recognition and facial expressions in the computer graphics community.
Okay, I think we ought to move on to the next speaker if we can. I'm sure all these short talks will generate more questions than we've got time to deal with at the moment. Let's keep in contact for